Hey, hello, and welcome to the show. It is me, JP, and it is time for JP's product pick of the week. And it's also time for me to dump a little bottle of bourbon whiskey that we might be using later over. It was capped. We're okay. Thank you for stopping by. Thanks for jumping in on our chats. We've got a YouTube chat up. Where'd mine go? I swear I just had it. There it is. Hello to Dave Odessa and Beata Graf of Delhagen and Warlenexus3169. Hello. Mike P0457. Thanks for popping by. And of course, we also have our Discord chat. I should say I can now show the YouTube chat. I forgot. There's the YouTube chat. Jump over there or head on over to our Discord. This is that. The Discord is at adafruit.it/Discord. Look for the live broadcast chat channel. That's where you'll see people hanging out. Hello to who's here? Hello to Paul Cutler and Blitz City DIY, Thin Man, Sam J. Ohio. Thanks for stopping in. And Beata Graf of Hagen said, "You're muted." No, not really. It's just on my end this time. Phew. I do have more than the previous number of little VU meters bouncing around that hopefully I will notice when those go still that I'm somehow muted. I'm also batteryless now. I've moved away. If you didn't know, I moved away from my wireless battery pack. I just have a normal pair of wired mics. So when I head over to the workbench for my other show and for other stuff I do in here, I'm still covered. That was the main benefit of a wireless mic pack, was walking around, but you know, issues with batteries and things. I buy way fewer batteries now, which I'm pleased to say. Also, let's see what else we doing here. I want to send you to this URL right here. Where is it? This. If you want to go check out this week's product pick before I even mention any more about it, then go to that URL. You can go to that QR code, and that will allow you to still watch this show from inside of the product page. It will also allow you to get 50% off. We had 100 of them stashed before the show, and I believe you can get up to 10 of them per customer if you have big plans. And no resellers allowed, but there are no rain checks or no back orders on these prices. We don't do that. We just sell it to you when we have it in stock, which is right now, and you can get it at this price until the end of the show or until it sells out, whichever comes first. So, as is customary on this show, before I even hint at what we've got going on, other than the thumbnail, I suppose, I'm going to have Lady Ada tell us about it, so take it away, Lamore.
This is the SGP40, which is the next generation of gas sensors from Sensirion. This was actually an NPI, which is why people might be like, this sounds familiar. So what this does is it has a built-in little piece of gas sensing element and inside, and a little like protector top, and it heats up the piece of silicon that's doped, and it can detect when there's volatile organic compounds. So this would be good for like detecting rotting fruit, for example, or alcohols in the air, or if you're laser cutting a material that emits off gases. This is what it would be good for. It's not good for particulate sensing. That's a PM 2.5 sensor. We stock those too. Different sensor. This is for gas compounds. So the SGP40 is I2C. It's very similar to the SGP30. However, one thing I do want to note is that this is being marketed by Sensirion as a more precise, better quality sensor. However, it does not spit out the effective CO2 or volatile organic compound index directly from the sensor. It gives you a raw value, and then you have to use their sensor processing library code, which we've ported over to Arduino. It wasn't too bad. It's in C. And then it will give you an index value from 0 to 500 based on how much organic gas is it detecting in the area. So it's kind of giving you like a qualitative value, not a quantitative value. One nice thing that's about the sensor is that if you pair it with a a humidity sensor or a temperature sensor, or both, that's even better, you can get better results, because humidity and temperature does affect gas sensors. And so you want to sort of like, if you give it the humidity and temperature, ambient temperature and humidity, it'll use that to kind of calibrate the reading out and give you a more normalized reading, because it can't measure the temperature on its own because inside there's a heater. So it can't know what the temperature really is. You need an external sensor to do that.
Yes, yes, indeed. That's right. That right there is, let me bring it up, the product pick of the week this week. It is the SGP40 MOX gas sensor. This is a Breakout with I2C, so you can plug it into pretty much any of your microcontroller or single board computer projects, and it has STEMMA QT ports on it to make it easy, no soldering required. We do include some header pins, and you can see we've got some little solder positions there if you want to mount that on a breadboard or a Perma Proto or do some other kind of wiring. But the easy way is plug and play with STEMMA QT. This runs in Arduino, it runs in CircuitPython and Python, and it also has a whippersnapper object, so you can plug and play inside of the whippersnapper using Adafruit IO if you like, in order to set that up with sort of a zero code solution. Let's see, let me go to this photo of it. You can see there it is a 16-bit raw reading that it gives you over a single I2C address, 0x59. You can't switch it. We don't have jumpers on it. It's a single address. You could use multiple I2C lines if your microcontroller supports that, or you can use a multiplexer for I2C. But for single use, single sensor use, it's very simple plug and play. And it combines multiple metal oxide sensing elements with a heater inside of the chip. I believe it also has a little filter on top, so it brings in air and it detects the volatile organic compounds, and then it gives you back a 16-bit raw reading. You can also use the library to get a VOC index, as Limor said, that's 0 to 500. And I'll show you that in a demo in a second with some little breakdowns of what those numbers mean. You can also pair this with a humidity and temperature sensor and get slightly better compensation readings. You can also enter in those values, which is what I've done in my code, since I just in this demo, I know roughly what the temperature and the humidity are in the workshop here. So let's get to, how about the product page? Right here, you can see this is normally $14.95. We have it for $7.48 today. There are 74 of them in stock, so they're moving at a decent rate. And you can find a lot of uses for this for indoor. It's not an outdoor, but for indoor gas sensing to make sure that your environment is safe, especially if you're doing things with paints and glues and alcohol and other VOCs. If you want to just make sure that things are safe, set one of these up. It's simple and easy. Speaking of simple and easy, if you take a look at the product page here, as you scroll down, wow, this is really tiny. Let me make that just a whole bunch bigger. If you scroll down here, you will get to a link for the primary learn guide right here. And I'll switch over that right now. This gives you all the usual stuff you expect. So an overview, we have a pinout page here that tells you what the different pins are on it. Pretty much comes down to voltage and 3-volt ground. The device can work at 5-volt and 3-volt logic levels. And then we have serial clock, serial data for I2C. And then the STEMMA QT connector to make all that easier. You can see we have setup and example for Arduino, Python, CircuitPython, and Whippersnapper. I'm going to show you a demo I've done in CircuitPython today. So let me switch over to this little view. So here you can see I've got my little SGP40 set up over I2C going to a Metro. And I have a little Q-tip here. This one has nothing on it right now, but what I'm going to do is dip that in a little bottle, a little airplane bottle of Elk Rider bourbon whiskey. Why not? And then if you take a look at the readings I'm getting right now in my REPL, we are looking at raw values of, oh wow, this is pretty high right now. So I turned off the air conditioning. So just this room, this is good for me to know, just this room is a little bit high in VOCs on its own. So I'm going to go ahead and dip this swab in here and hold that under the sensor. And we should see that start to rise pretty quickly. So yeah, now we're jumping from 320 to over 400 as the VOCs increase, the resistance on the MOX sensor decreases. That's why you'll see that raw value going down as that index value goes up. So now we're getting, with that bourbon whiskey sitting right there underneath its nose, we're getting to the point where this really is not considered to be a safe amount and should probably be cleaned off. Let me see. Let me open up a different, bear with me one second. I have another copy of this that I put a little note at the top of. Let's see, why is that not updating? Well, that's weird. I don't know why oh, it opened it in a different window. Let me just paste this into here. So here was some guidelines here. So VOC, that VOC index 0 to 100 is really clean air. 100, 200, still acceptable. Don't worry about it. 200 to 400, you should ventilate / purify. And then 400 to 500, ventilate intensely. So you shouldn't just be huffing whatever that sensor is huffing right now. So I'll move that out of the way. In fact, let me turn on, I'll bring some air into here, which I usually do have air coming in, but I turn it off sometimes for avoiding microphone noise. Yeah, I'll just set that on ventilate. It's not rapid, so I think that especially with this level of saturation on the sensor, it's going to sit in there for a while. I don't know if I can blow that off. Let's see. I'm going to try turning on a little air blower, one of these little air blowers. And let me just blow that in the vicinity. I'm also going to move my Q-tip far away. And yeah, it's not doing much. I'll leave that to air out on its own as we look at the code here. It's actually quite simple. So you can see here I'm importing time and board. So I get pin definitions, just mostly for that STEMMA QT port. And there is a dedicated library here, Adafruit SGP40. Here you can see, rather than setting up a separate sensor, I've just told it, okay, my relative humidity right now is about 45%. My temperature is around 72. And then I have a little function here to turn the Celsius to Fahrenheit I2C setup, the SGP object as SGP40 on the I2C bus, and then my temperature C using that function. I'm printing out the temperature and humidity just at the beginning of this sketch, since I'm not repeatedly checking that. And then the main loop here, so raw equals sgp.raw. That's all you have to do to ask for that 16-bit value off of the sensor. And then this little convenience command here inside the library is what's giving me the VOC index. I just say sgp.measureIndex. I tell it my temperature, I tell it my relative humidity, it knows the raw value, it combines all of that, and it spits out the index here that we're seeing. So right now, yeah, still 493. Before I let myself asphyxiate here on the bourbon fumes, I'm going to turn on my main exhaust that's up in the roof as well. Hopefully that doesn't get too loud. But I'd love to see those numbers go down while we're still here. And let me just also check the chat to see if there's any questions. Darth Paul mentions Moxie. I love Moxie. I wonder what the Mox sensor thinks of Moxie. This is a good question. Future breathalyzer project, indeed. And yeah, so one other thing to mention. So I think I listed this at the top of the code here. You want to give this a few minutes to develop a baseline in clean air. So you kind of need a starting point to get it calibrated. I believe the Sensorion docs say ideally you get 24 hours of clean air, and then you can rely on it even more. So depending on your application, how sensitive it is, you could consider that. Okay, with my exhaust there and my air being brought in, this thing is very slowly starting to admit that the bourbon is not sitting right in front of it anymore. You can see that number dropping. I don't know if there's a way to get that to move more quickly. I haven't got enough experience with the sensor to know, but I don't believe that level could possibly be that high right here in front of here, since I've moved the VOCs away. But if anyone knows, has experience with that, let me know what you think. Let's see. Dana Camp, will this detect rotten eggs in an incubator? That is a good question. I think I don't know the answer off the top of my head. I think the line of questioning is going to be both is the sulfur coming off a rotten egg considered to be a VOC? And then also the Sensorion docs may have a little more detail on that. So let me jump over to the Learn Guide here. If you look in the Learn Guide on the left, we have this downloads page. And I'm going to go to this SGP40 datasheet that's on Sensorion's, or we've downloaded the PDF, but this is the Sensorion datasheet for this. So, as always, I like to say, what's it for? They say it's a MOX-based gas sensor for indoor air quality applications. And let's see. This talks about their algorithm mapping, sensor performance, limit of detection. They say ethanol in specified range, so I guess that's their baseline comparison is clean, fresh air versus ethanol. Let's see, electrical specifications, interface, output, measurement index. Yeah, there's a visual representation of that, chunks of 100 VOC index values. So the built-in sensor, startup behavior, and then this is just about the device itself. I'm going to look this up. Let's take a look at, is sulfur a VOC? No, pure sulfur is not a volatile organic compound because it's a solid element. Okay. One thing that I think Lady Ada mentioned is you could use this for rotting fruit, and that's because rotting fruit tends to emit ethane, I think, as the sort of fermentation of the sugars occurs in rotting fruit. I think you're getting an ethanol compound. Let's see. Ooh, sulfur compounds are kind of contamination for most Vox sensors and similar. Oh, interesting. Yeah, so I think you need a different sensor for that. One other sensor to look at, which we don't have in stock right now, also Sensorion, is the SGP41. This one combines a VOC and a, is it a nitrogen sensor, the NOx. I'm presuming. What is NOx? So this one here, we don't have in stock right now, but this one gives you both a VOC and an NOx reading. Let's continue this query. What is NOx gas? Nitrogen oxides. Formed during high temperature combustion. Major pollutant. Yeah, so that sensor has, I still don't think that's going to cover sulfur though. H2S is the rotten egg, turns into H2SO4. Let me bring up this very helpful comment over in the Discord, I believe. Yeah, from Ion U2, Darth Paul. NOx is NO and NO2. Okay, there you go. So if you have some sensing needs that this, not that one's out of stock, but this one we've got here today covers, go pick one up. We have them, as I said, for half price just today during the show. Let's see, let me make that a little bigger. Our stock, we have 63 of them left, so you have a little bit of cushion there if you want to think about that for a minute. But the price will go up soon after the show is over, so don't wait too long if you think that's for you. Let's go ahead and take that. Oh, you know what? I've got a battery pack on this Metro also, so we can unclip that. Oh no, my battery pack is off. There we go. I'll turn that back on. You can also see the sensor has a nice little power LED on it, just so you know that it's on. There's my Metro. So I think that is gonna do it for today. That right there, that is the product pick of the week this week. It is the SGP40 MOX gas sensor in STEMMA QT format. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. I'll see you soon. Bye-bye.